Hello everybody. Today I want to discuss PAM, P-A-M. It stands for Plug In Authentication Modules. Before we start talking about PAM, it's important to understand exactly what authentication is, really. Authentication is how computers verify to each other that they are who they say they are, or how a computer verifies that a user, a person, is who they claim to be. Authentication happens between a computer and a user, or between a computer and a network, or a computer and the internet. It could happen anywhere along the line. Authentication even happens sometimes with certain network peripheral devices. What authentication is most commonly is when either an operating system to log on to your computer or to relog on after the screen goes blank, either one, or when you're logging on for the first time, when the computer will ask you for a username and password. Okay, username and password is one method of authentication. There are others. There's multi-factor authentication. There's biometric authentication. There's many types of authentication, but most commonly, and what we will use as an example, is username and password. One of the things that makes Linux a little different than Windows is that, unlike Linux, Windows, the operating system, has the authentication built into the operating system. So when you buy Windows, Windows 7, Windows 10, Windows 8, doesn't matter. Okay, Windows comes with a certain method of authentication built in. And the last time I checked, it uses what's called a hashing algorithm on the password. Windows uses MD5 as a hashing algorithm, which as of a few years ago was cryptographically broken. So that sort of puts Windows at a little disadvantage right off the bat, because if, let's say, Linux were using MD5, which it used to, but it doesn't anymore, you don't have to reinstall the whole operating system. You change the plug-in authentication module, and everything else stays the same, totally transparent to the user. Another thing that authentication does is it keeps security separate from applications and the kernel. Because you're running your applications in the operating system, you don't want those applications to get direct access to the kernel being the very root, the core of the operating system. You want to protect that as much as you could. If the authentication system is later shown to be insecure, like it was in my above-mentioned example of MD5 with Windows, you can just switch to another PAM. You update your PAM, and it carries all the way down the line. So, those are several key advantages. Okay? Linux, as I mentioned, does not have built-in authentication. It does not have a customer lock into a particular authentication system. You could use any authentication system you want in Linux. You just have to be able to link the operating system to whichever authentication system you're using. So what PAM is doing is it's providing a flexible selection of authentication systems for differing contexts, purposes, and applications. So instead of having one PAM forever, or one authentication system running everything, all the authentication that is being done, as is done on Windows, with Linux, you could have different applications using different PAMs all at the same time. So that's good. Okay, the purpose, okay, is because instead of building the authentication code into each application, PAM provides what they call shared libraries that keep the authentication code separate from the application code. Okay, remember when you have a computer, it's executing everything in memory and you write lines of code. The PAM code and the application code are kept separate. The techniques for user authentication stay the same from application to application. That's what makes it transparent to the user. The authentication method can remain constant, yet the underlying mechanism that's doing the authentication is entirely different. This allows the system administrator to change the authentication mechanism for a given application without even touching or in any way modifying the application itself. PAM is also what they call modular. And this modular provides authentication for a variety of system entry services, such as login. You have to log into your machine, the super user command, the sudo command. There are a number of different authentication techniques suitable for different environments, such as RSA, DCE, Kerberos, and smart cards. They can all be supported by PAM. Different PAMs, every one of them. PAM allows the system administrator to integrate the system services with different authentication mechanisms without changing the code for the service. So you have all these different services running. They could all be using a different PAM all at the same time, and you don't have to touch the underlying application authentication mechanisms. All you have to do is link them to the appropriate PAM, and they will then execute it. As I mentioned, PAM uses what they call these shared libraries, which in Linux, okay, they can be called by an application. They're located in the /lib/security subdirectory. Okay, so that's /lib/security. The administrator can change the authentication mechanism without even touching the application. Okay, let's talk about some different types of authentication mechanisms for a minute. Okay, authentication mechanisms provide authentication for system entry services such as login, FTP protocol, system shutdown, things of that nature. Okay, modules for differing authentication mechanisms such as Kerberos, RSA, smart cards are also supported by PAM for other particular applications. So you log into your system, you use one PAM. You want to run a specific application, it authenticates you through another PAM. At the same time, you want to run yet a third application that can be using its own PAM specific to it. So it gives you incredible flexibility. And it integrates system services and applications with different authentication mechanisms all working together flawlessly. That's one of the beauties of it. Now, PAM also needs configuration files as well, because like with anything else in Linux, things have to be configured. So, like most configuration files in Linux, it's in the etc, the etc subdirectory. That's where you find most of your configuration files in Linux. Within the etc subdirectory, there is another directory called PAM, PAM.d. That is where you'll find all of your PAMs and all of your PAM configuration files that go with the associated PAMs. These configuration files determine how the applications will use the authentication, and it determines the method of authentication. This is fairly important. By method of authentication, I mean whether it's two-factor, whether it's biometrics. Are you going to have to be running another device such as a fingerprint reader or a retina scanner? Is it just plain username password? All this is determined as being a method of authentication and can be set up by editing this configuration file. If you want to edit PAMD, you need to use care and attention. A lot of care and a lot of attention, because one simple mistake in editing a PAM file, especially if it's the one that logs you in, and you can be locked out of the computer, and Linux is extremely tough to hack into. So if you mess up the PAM to log yourself in, you're in trouble. So because of that, and that is why it's very important, and I strongly recommend that you keep a root TTY session open until you have thoroughly finished testing the changes you made. Remember, Linux is multi-user, and if you keep a root TTY session open, and then you make your changes in another session, you log off. If you try to log back on and you're locked out by the PAM, you can go back in and re-edit the PAM through the root TTY session. So you don't want to close all your windows. You want to keep a root session open and work through other TTY sessions, multiple, and you can even have multiple root sessions, but you want to keep at least one open so that you could re-enter your system and reconfigure those files if you're locked out. Okay, so you could also restore from a backup, keeping a root TTY open. So that's why I recommend that. PAM, like everything else, sends error messages to a file rather than the screen in Linux. Remember, Linux is high security. So the error messages get sent to a file, which an administrator can then later look at. It does not get sent to the screen unless you want it to, for security, so that potential attackers can't see what's going on. To prevent malicious user from seeing PAM info is one of the reasons, because then you get feedback about what you're doing wrong, why isn't it working, and then it can actually help the hacker break into the system. Now, these log files are stored in the VAR /var/log secure, or /var/log/messages. It's going to be stored in one of those, either the /var/log secure or messages. Okay, that's where the error messages go. So thank you very much for watching, and I hope everybody learned a little something about how plug-in authentication modules work in Linux.